In this video, we will be discussing analyzing and interpreting data. We will be focusing on choosing the best measure of center and variability. By the end of this video, you will be able to choose whether the mean or median is the best representation of the center of a data set. So let's take a look at these two data sets. So I'm going to graph the first one. So I've got a point at 2, point at 3, point at 5, and a point at 6. And then on the second one, I have a point at 2, point at 3, point at 5, and a point at 10. So it says calculate the means of the two data sets. Well, when I calculate the mean, I add up all of my data points. So for the first one, I'm going to take 2 plus 3 plus 5 plus 6. And then since I added up 4 numbers, I'm going to take that answer and divide it by 4. And when I do that, I come up with a mean of 4. Do the same thing for the second data set. And when I do that, I come up with a mean of 5. And it says, what happens to the mean when the value of 6 is replaced with the value of 10? Well, it moves one number to the right. Changing the 6 to a 10 adds 4 more to the total. When you divide by 4, it adds another group, which slides the mean to the right one spot. So here are the same data points graphed on my dot plot, but this time it asked to calculate the medians of the two data sets. Well, again, when I do that, I start here and then go over to here, then I start here and go here. So my median is in between. So for my first one, my median is 4. Same thing here, cross off, cross off, cross off, cross off. My median is here. So for here, my median is also 4. So what happens to the medians when the data value of 6 is replaced with 10? Well, nothing happens. There are still only 4 data points, which keeps 4 as the middle value. Let's take a look at these two data sets. So I'm going to graph the first one. So I'll put a dot here, dot here, a dot here, a dot here, and a dot here. And then for my second one, I'm going to have a dot out at 25, one at 50, one at 55, and then 2 at 60. So now, using those same dot plots, I'm going to determine the mean, the median, and the mode. So for my first one, my mean is 55. My median is also 55. And my mode would be 50 and 60. So for my data set 2, my mean would be 50. My median would be 55. And my mode would be 60. Let's take a look at the median of these two data sets. What do you notice about the medians for each data set? Well, I notice that nothing happens. It stays the same. This one stays at 55, and this one stays at 55. So nothing's happening here, even though I moved this data point out to here. What happens to the mean with these two data sets? Well, when I look at it, you notice that it becomes 5 less because I went from 55 now to 50. So moving this data point here out to here decreases my mean by 5. Why are the medians of the data sets the same, but the means of the data set different? Well, the medians stay the same because there are still only 5 data points, which keeps 55 in the middle of those. The mean decreases by 5 because changing from this 50 to this 25 subtracts 25 from the total. And when you divide by 5, that's taking away 5 groups of 5, which then slides the mean value 5 spots to the left. What are the distributions of the two plots? Well, the distribution of plot 1 is more symmetrical, and plot 2 is more skewed left. So, how do the values of the mean and the median appear to be affected by the distributions of the two dot plots? Well, when it's skewed left, it pulls the median to the left, similar to the skew. The smaller values decrease the total, which decreases the mean and moves it to the left of the number line. Just how this just how the skew pulls the tail of the graph to the left on the number line. Let's take a look at this data. So we're going to construct our dot plot, and in doing that, it should look something similar to this. So determine the mode for the number of minutes spent exercising. So when I do that, my mode would be looking like here and here, which is 30 and 60 minutes. Determine the median for the number of minutes exercising. Well, when I figure that out, I come up with 40 minutes. Determine the mean for the number of minutes exercising, and I came up with 59 and 6 repeating minutes. Would the mean or the median be a better measure to describe the center of the exercise data? And explain your reasoning. Well, the median would be a better choice, and the reason would be is that the median is in the center where the mean is pulled to the right because of this amount. And the graph is skewed right, so the mean is being pulled right. So the median is going to be the better choice. Here I have a stem and leaf plot. How many students are represented in the stem and leaf plot? Well, when we count up all of the leaves, we come up with 25 students. What is the mode? Well, it looks like the mode would be right here because there are 3 sevens. So my mode would be 87 students. What is the distribution of the data? Well, when I draw out kind of my line here, it looks like it is skewed left. Do you think the mean test score is greater than or less than or about the same as the median test score? Well, I think that the mean will be less than the median score. So let's determine the mean of this data set. Come up with 80 and 56 hundredths. And for the median, I come up with 85. So my mean, which we said was 80 and 56 hundredths, is less than my median, which is 85. And so in this case, my median would be a little bit better choice on here because it's going to represent more of the center because of my data being skewed left. How many students are represented in the histogram? Well, in this I have 10. Here I have 7. Here I have 5. And here I have 3. That gives me a total of 25 students. What distribution do I have for the histogram? Well, I start here and I kind of go up for my peak on the right. So that means my data is skewed left. And can I determine the mean, the median, and the mode for this data by looking at the histogram? And my answer would be no, I cannot, because the histogram deals with ranges and not exact data points. Do you think the mean number of hours spent playing video games is greater than, less than, or about the same as the median number of hours playing video games? I would say that the mean is less than the median because the data or the graph is skewed left, and that means it pulls the mean to the left as well. And if the mean and the median were equal, and then I pull the mean to the left, going left on the number line is less than where it started off as. So let's sum it up. Which is a better measure of center and why? If the data is symmetrical, then the data is clustered around the center. And that means the mean and the median are equal. The mean is the better choice to represent the center of the data set. If the data is skewed left, then that means the data is clustered on the right with a skew or tail to the left. That means the mean value is going to be less than the median value because it's pulled to the left just like the skewed data is. So therefore, the mean is the better choice to represent the center of the data. If the data is skewed right, the data is clustered on the left with a skew or tail to the right. The mean value is greater than the median value because it is pulled to the right, just as the skewed data is. So that means the median is a better choice to represent the center of the data. So if it's symmetrical, the mean is the best choice. If it's skewed left or skewed right, then that means the median is the better choice.